Okay, so you're a computer engineering student. You've got the basics of agentic AI down right. Well, consider this your crash course on what's new and what's next. We're going deep on a paper all about recent advancements, really geared towards, developers like you.
Yeah, for sure. This isn't just another dry research paper, it's all about making those connections, taking what you already know about the fundamentals and seeing how it's all playing out in real-world applications, especially in things like automotive AI, which is blowing up right now. It's a mix of hardcore theory, ways to actually measure if these AI agents are doing what they're supposed to, and of course, some really cool real-world examples to bring it all home.
So we're on a mission here. We're going to pull out the absolute key takeaways from this paper, the stuff that's going to level up your understanding, building on what you already know about agentic AI. We're talking core concepts and real-world implications,
Yeah.
the stuff that matters most for someone with your technical background. Sound good?
Sounds like a plan. But just to make sure we're all on the same page, let's do a super quick recap of what makes an AI agent, well, an AI agent, an entity that can check out its surroundings, its environment, and then make smart moves using a bunch of tools to hit those goals it's been given. And the kicker is it does all this on its own, figuring out the next steps autonomously.
Right. And the architecture of these agents, it all boils down to three main ingredients, yeah. You've got the model, the language model, that's the brains, the operation, making the decisions, doing all the thinking and planning. And then there are the tools, how the agent actually interacts with the world outside, like calling up APIs or grabbing data from somewhere.
And tying it all together, you've got the orchestration layer. This is the engine, the driving force behind the whole show. It takes in all the information, manages the agent's memory, and uses fancy techniques like React or chain of thought to figure out the best move to make next. It's a constant back and forth, this cycle of thinking and doing.
Okay, so we've got those basics covered. Now, this paper we're diving into, it's really like a 102 guide, taking things to the next level. So let's jump right into something that caught my eye, something called Agent Ops. Now, this seems like it's right up your alley as an engineer. What's the deal with Agent Ops?
Absolutely. Think of Agent Ops as this specialized branch of Gen AI Ops, which stands for, generative AI operations. It's like how DevOps revolutionized traditional software development, and then MLOps came along to tackle the unique challenges of dealing with machine learning models. Agent Ops is all about efficiently deploying those AI agents, managing them, and scaling them up for real-world applications, making sure they're actually working as intended.
So what are we talking about here? What are those unique operational things you need to think about with agents?
Yeah.
Stuff that goes beyond what you'd worry about with regular software or even those ML models.
Great question. The paper highlights a few key areas that are specific to agent ops. You've got managing both the internal tools, like the agent's own code and functions, and then the external tools, things like APIs and all those data sources it needs to tap into. Then there's the orchestration logic itself, the agent's brain, how it's structured, how it makes decisions. And memory management is huge, both short-term and long-term. And the way an agent breaks down those complex tasks into smaller bite-sized steps is also super important and unique to agent ops.
But hold on, we're not throwing out everything we've learned from DevOps and MLOps, are we? Those principles, they still hold true, right?
Absolutely, they're still the foundation. Things like version control, that whole CI/CD pipeline, continuous integration and continuous deployment, rigorous testing, detailed logging, and security. Of course, can't forget security. These are all still absolutely fundamental for agent ops. The paper actually stresses that agent ops builds on these established practices. It's not reinventing the wheel. Like,
Right.
if your agent uses a tool to call an external API, you still need to handle all those standard API management things like authentication, error handling, the usual suspects.
It's like we're building on top of what we already know.
Yeah.
Speaking of building, the paper gives a rundown of all these other ops terms that are flying around. It's almost like an alphabet soup of ops. DevOps, MLOps, and what else?
It can definitely feel that way. So yeah, you've got DevOps for your good old-fashioned deterministic software. MLOps, of course, for those non-deterministic machine learning models, always keeping you on your toes. Then you've got FMOps, which is all about handling those massive foundation models. PromptOps is focused on, well, prompts making sure they're optimized and managed properly. RAGOps tackles the operational side of retrieval augmented generation. And Agent Ops, the new kid on the block, is all about managing the unique life cycle of AI agents. Lots of ops, but they all serve a purpose.
And they all seem to have this one thing in common, the importance of metrics. You always hear that, right? Can't manage what you don't measure. Applies here too, right?
100%. Just like in DevOps and MLOps, metrics are the lifeblood of agent ops. They give you that clear picture of how your agents are performing, help you zero in on areas where you can make improvements, and let you compare different versions side by side, apple to apples as you tweak and refine your designs. This whole data-driven approach, it's at the heart of keeping those agents running smoothly.
So we know we need metrics, but when we're trying to figure out how successful an agent is, what are the things we should be keeping an eye on?
The paper makes this really important distinction between two levels of success. First, you've got those high-level business outcomes, the big picture stuff like how much revenue is being generated or are our customers actually happier, more satisfied. A single agent might not directly move the needle on these, but these are the ultimate goals, the North Star guiding its development.
Makes sense. Keep the big picture in mind, right?
Yeah.
But then there are those more specific metrics, the ones that are focused on the agent itself.
Exactly. Most agents are built to do specific tasks, so the goal completion rate is a big one. But you also got to break down those high-level goals into those individual steps or those little interactions with users. Measure how well the agent's doing on each one of those. That's how you get a much clearer understanding of where the agent might be struggling, where it needs help.
So it's like zooming in on the details. And I'm guessing those standard application monitoring tools, they're still helpful here, right? To get that granular data.
Oh, absolutely. All that usual application telemetry stuff, like how quickly the agent is responding, how many errors it's throwing, how much of those computing resources it's chewing up, those are still super relevant for agents. Just because it's AI doesn't mean the underlying software performance doesn't matter. It all has to work together smoothly.
Now, here's something that really seems unique to these AI agents, and the paper talks about this a lot: the importance of getting feedback from actual humans, people.
That's gold. You can learn so much from those simple feedback mechanisms, like just a thumbs up or thumbs down after the agent does something, or even a short feedback form, asking people what they think. It gives you those really valuable insights into what's working and what's not from the people actually interacting with the agent. And that feedback can come from anyone, right? From the end users, the people using the app, but also from internal testers, domain experts, anyone who can provide valuable insights.
Makes sense. Diverse perspectives are valuable.
Yeah.
Right? Now, the paper also talks about this concept of a trace for really digging into the nitty-gritty of what's happening inside the agent, especially when things go sideways. I imagine that's like a lifesaver for a developer, being able to trace what's happening.
Oh, it's a game changer for sure. Imagine a trace as this super detailed step-by-step log of everything the agent is doing under the hood. It's not about tracking every single calculation. That'd be overkill. But it's about capturing those key decisions, the calls it makes to those external tools, the steps in its reasoning process, the whole sequence of events that led to a particular outcome. When those high-level metrics start flashing red or users are giving you the thumbs down, a trace lets you rewind the tape, see exactly what went down step by step. Super valuable for debugging and figuring out how to make the agent smarter.
Okay, so we know how to keep an eye on those agents once they're out there in the wild doing their thing. But what about when we're building them, back in the lab, refining them? That's where agent evaluation comes in, right? Making sure they're actually doing what they're supposed to.
Bingo. The paper makes it crystal clear. Rigorous evaluation, ideally automated as much as possible, is mission critical. It's what takes your agent from a cool proof of concept to something you can actually trust, something ready for prime time. And here's the key difference with evaluating a standard generative model. With agents, you're not just looking at the final output, the answer it spits out. You have to look at the entire decision-making process, how it got there.
And the paper breaks down agent evaluation into three main parts. Let's start with the first one, figuring out what the agent is even capable of doing. Like, what are its limits?
Right. You need to understand those fundamental abilities, the strengths and weaknesses of your agent. The paper suggests starting with those publicly available benchmarks and technical reports, see what other people have done, what works, what doesn't. This gives you a sense of where things stand, what's possible, what are the common pitfalls you need to watch out for.
So things like those benchmarks that test how well an agent can use tools, or how good it is at planning and reasoning through those tricky scenarios.
Exactly. The paper specifically mentions a few. BFCL, which is the Berkeley Function Calling Leaderboard, PENCH, which is all about evaluating how agents use tools, and PlanBench for figuring out how good an agent is at planning and reasoning. And here's a key point. While those big, all-encompassing benchmarks like Agent Bench try to measure the overall end-to-end performance, they might not be granular enough. They might not give you that fine-grained detail you need to pinpoint exactly where your agent is rocking it or falling short. It's interesting to see these more specialized leaderboards popping up, things like Adyen's Data Analyst Leaderboard, which focus on very specific tasks and can give you those targeted insights.
So those public benchmarks give you a good starting point, a reality check on what's possible and what to look out for when you're building your own agent.
For sure, they even help you spot those common failure modes. But ultimately, you need to put your agent through its paces, test it across a range of scenarios that are relevant to what it's supposed to do. And you're not just looking at the final result, but the whole journey, the sequence of actions it took to get there. The paper calls this the trajectory.
And that leads us to the second part of evaluation, checking out the trajectory
Yeah.
and how the agent is using its tools. This seems super useful for debugging, figuring out where things went wrong.
Oh, it's essential. The trajectory is basically that detailed roadmap of actions an agent takes to arrive at a solution. By comparing the steps you thought the agent should take with what it actually did, you can spot those inefficiencies, those logic errors, or maybe it's using the wrong tool for the job.
The paper talks about different ways to actually measure how well the agent's trajectory aligns with what you'd expect, right? Like some kind of scoring system.
Right. It introduces 6 different automated metrics for trajectory evaluation, all based on having a ground truth trajectory to compare against. You've got exact match, which is the strictest. The agent has to follow the expected sequence to the letter. Then there's in order match, which is a bit more lenient. It checks if those crucial actions are performed in the right order, but allows for some extra steps that might not be critical. Any order match just wants to see if all the necessary actions were taken, doesn't care about the order. Then there's precision and recall, which tell you how many of the predicted tool calls were actually on point and how many of the necessary tool calls from the expected trajectory were actually made. And lastly, single tool use, which is helpful for checking if the agent has figured out how to use a specific tool effectively when it's needed.
So that's a pretty comprehensive set of metrics. And like the paper points out, which ones you use depends on what the agent is supposed to be doing.
Exactly. Some tasks are very rigid, need a precise sequence of actions, while others are more flexible, allow for some creative problem solving. The catch here is you need that predefined ground truth trajectory to compare against. But the paper does mention some interesting research on using agent autorators to help automate this process, creating and comparing those trajectories. That could make this kind of evaluation way more scalable, less manual work.
So we've looked at figuring out what the agent can do, checking its path, and now for the final piece, evaluating the actual outcome, the agent's response, the answer it gives.
Right. The bottom line is, did it achieve its goal? Did it do what it was supposed to do? To figure that out, you need to set those clear success criteria that make sense for your specific application. Like if it's a customer service chatbot, did it actually solve the user's problem? To automate this, you can use what's called an autorator, basically another language model that acts as a judge, scoring the agent's performance. You give it the original prompt, the agent's response, and those evaluation criteria you defined, and it gives you a thumbs up or thumbs down.
And the paper really emphasizes that when you don't have a clear-cut right answer, defining those evaluation criteria for the autorator is super important. You have to tell it exactly what a good response looks like.
Right, absolutely. Those criteria, that's what you're measuring the agent against. You can often find these pre-made sets of criteria in various libraries, and then you can tweak them, customize them to fit your specific needs, match the nuances of your application.
Now, with all these fancy automated evaluation techniques, the paper makes it clear that we still need humans in the loop. You can't just automate judgment completely, can you?
Not yet, at least. Agent development, it's still a rapidly evolving field, and there are so many things that are tough to measure or automate, especially when you're dealing with those complex goals or just the unpredictable nature of AI. Human evaluation, you can't beat it for things like creativity, common sense reasoning, those subtle things in language. Humans bring that broader context, and they can give you valuable feedback to improve the agent, tweak its design, boost its performance, and their feedback can actually help you fine-tune those automated evaluation methods, make them more accurate.
And the paper mentions a few ways to get that human feedback, like having them directly rate the agent's performance, comparing the output of different agents side by side, and even doing full-blown user studies, watching people interact with the agent in the real world.
Exactly. So human expertise is still essential. It's what makes sure those AI agents are developed and deployed responsibly and effectively, not just technically impressive, but actually useful. The paper also mentions some of the broader challenges we're facing with agent evaluation, like getting enough high quality data to train those evaluators, the limitations of using LLMs as judges, and the complexities of evaluating agents that deal with multiple types of data or operate in messy real world environments. It's a field that's constantly pushing the boundaries, always evolving. There's a ton of research happening on process-based evaluation, using AI itself to help evaluate agents, developing those standardized benchmarks, and a big push towards making agent behavior more explainable, so we can understand why they do what they do.
Okay, so we've covered a lot of ground with building and evaluating individual agents. Now, the paper shifts gears and talks about these systems with multiple agents working together, like a team. What's the rationale behind that kind of architecture? Why go with a team of AI agents? What's the advantage?
It's all about tackling those bigger, more complex problems that are just too much for a single agent to handle. Think of a multi-agent system as a team of specialists, each with its own set of skills, maybe even running on a different language model, but they're all working together, collaborating to hit that larger goal. It's like assembling the A-team. Each member brings their own unique expertise to the table.
So what are we talking about here? What are the concrete benefits? What's in it for the developer or the end user?
The paper highlights a bunch of advantages. First off, you can get more accurate results. Different agents can cross-check each other's work, make sure things are solid, or they might approach a problem from different angles, which can lead to more creative solutions. Then there's efficiency. Things get done faster because those agents can split up the work, run those tasks in parallel. Those really complex tasks, the ones that would make a single agent sweat, become more manageable when you break them down into smaller chunks and assign them to those specialized agents. Multi-agent systems also scale better. You can just add more specialists as your needs grow. And they can even handle failures better. If one agent crashes or runs into a problem, the others can pick up the slack, keep things running. And maybe most importantly, by using different skills and perspectives, you can reduce the chances of hallucinations or biases creeping in, those weird things that can happen with a single agent.
So how are these multi-agent systems actually structured? Are there common ways to organize and coordinate these teams of agents?
The core principles you see again and again are modularity, breaking down that big problem into smaller, self-contained pieces that each agent can handle. Collaboration, making sure those agents can talk to each other and work together smoothly, and sometimes hierarchy, where you have some agents acting like managers, coordinating the work of others. The paper gives some examples of the types of agents you might find in these systems. You've got planner agents, the ones who figure out how to break down those high-level goals, retriever agents, the research whizzes who fetch relevant info from different sources, execution agents, the doers who carry out those actions or tool calls, and evaluator agents, the quality control folks who check the work of other agents, make sure things are up to snuff.
So that when you're actually designing these multi-agent systems, are there any established patterns or blueprints that developers can follow?
Oh, yeah, for
Cool.
sure. Just like in regular software development, there are common architectural patterns that define how the agents interact, who does what, and how they pass the baton, how those roles and responsibilities are spread out. The paper walks through a few key design patterns. There's the sequential pattern, where those agents work in a line, one after the other, like an assembly line, passing their output down the chain. Then you have the hierarchical pattern, where a manager agent calls the shots, coordinates the work of several worker agents, the classic boss-employee relationship. The collaborative pattern is all about sharing, those agents share information, resources, those intermediate results to get to that common goal. And then you've got the competitive pattern where multiple agents might work on the same problem independently, and then you pick the best solution, survival of the fittest. The paper even mentions this overcooked AI example, it's a game, to illustrate competitive multi-agent learning. They actually learn by playing against each other. It's pretty cool. And the paper also has a visual reference showing you different ways these multi-agent systems can be set up, different topologies.
So these patterns, they give you a framework, a way to think about building these more complex AI systems. And they have real benefits for businesses, right? Like streamlining those processes, making automation more reliable, all that good stuff.
Exactly. Multi-agent systems, they're a powerful way to tackle those messy real-world problems, the ones that are just too much for a single AI agent to handle. They let businesses scale up their AI, roll it out more widely, with more flexibility and reliability.
Now, beyond those big picture patterns,
Yeah.
what are some of those specific architectural components that developers should be thinking about when they're building multi-agent systems?
The paper breaks down those key architectural elements that are essential for making sure those agents play nice together. You've got the interaction wrapper, which is like the translator. It handles how those agents talk to the outside world and to each other. Robust memory management is huge. Got to make sure those agents can remember what they've learned, both in the short term for the current task and in the long term for those broader lessons. They even talk about reflection. That's where an agent analyzes its own past experiences, figures out what's worth remembering and sharing. Cognitive functionality, that's where techniques like chain of thought and react come in, giving those agents the smarts to reason and plan effectively. Tool integration is key. Got to give those agents the right tools for the job, let them tap into those external capabilities. Then you have flow routing, which is like air traffic control that directs those tasks and information, make sure they get to the right agent. Feedback loops and reinforcement learning are crucial for continuous improvement, letting those agents learn from their mistakes and get better over time. And last but not least, you need agent communication protocols, those standardized formats and methods for how agents exchange info, especially important when those agents are spread out or working on those asynchronous tasks. Oh, and the paper also highlights the importance of this agent and tool registry as like a central hub for finding and registering all those agents and tools that are out there, keeping track of what they can do and how well they perform. There's even a diagram in the paper that shows how those multi-agent interactions can happen.
With all these agents buzzing around, interacting, coordinating, it seems like there would be some unique challenges, things that pop up specifically in those multi-agent systems that you wouldn't see with a single agent. Just the sheer complexity of it all.
You nailed it. The paper outlines some of those key challenges. Task communication, for example, is still pretty basic in most multi-agent systems. They often rely on those unstructured messages instead of using more sophisticated ways to manage those asynchronous tasks. Task allocation can be a real headache, figuring out which agent should handle which piece of the puzzle, and setting up those feedback loops across multiple agents that often requires a lot of manual tweaking. Coordinating the reasoning processes of all those independent agents, making sure it all makes sense, that's no easy feat. And managing all that context, all the info flying around when multiple agents are working, that can easily get overwhelming. And of course, these systems can be resource hogs. They can eat up a lot of computing power and take longer to run, which can lead to higher costs and that dreaded latency. And the complexity just keeps growing as you add more agents and those interactions become more intricate.
So how do you go about evaluating these more complex multi-agent systems? Do the evaluation strategies we talked about for a single agent still apply, or do you need a whole new playbook?
The good news is, according to the paper, multi-agent evaluation builds on those same principles we discussed for single agents. Your core agent success metrics, those high-level business goals, the goal completion rates, those standard application performance measures, they're all still crucial. And you can still use tracing to understand the step-by-step execution of the whole system, see how it's all working together. The two main automated evaluation approaches we talked about, evaluating those agent trajectories and assessing the quality of the final response, they're still very relevant. In fact, with multi-agent systems, you can often evaluate the trajectory of each individual agent involved in a task, see how they're each contributing. And you can still evaluate the overall final response of the system using similar criteria as you would for a single agent.
But there must be some new questions that pop up, right? When you're evaluating a team of agents, you have to look beyond the individuals and see how well they're working together.
You got it. You got to think about things like, are the agents actually cooperating effectively? Are they coordinating their actions? Was the overall plan generated by the system sound? Did those agents stick to it? How efficiently are those agents being used? Are you using the right type of agent for the job, and are you using them wisely? And how well does the system scale? Does it maintain performance and reliability as you throw more agents at the problem or make those tasks more complex? These are the big questions that guide the evaluation of a multi-agent system. And while you're using the same tools and techniques, the analysis gets more involved, more layers to peel back because you're looking at those interactions, those dependencies between those autonomous entities.
Now, the paper talks about this really intriguing development called Agentic RAG. What is that all about? Why is it being presented as such a big step forward?
Agentic RAG. It's a major evolution in how we approach retrieval augmented generation. That whole process of retrieving information and then using it to generate a response. In traditional RAG, you retrieve the information from your knowledge base and then feed it to a language model to generate an answer. But this approach can struggle with those complex or ambiguous queries, the ones that aren't straightforward. Agentic RAG brings in those autonomous retrieval agents that can actually refine the search process, make it smarter using reasoning and actions. They can think about the query, decide if it's good enough, and if not, rephrase it, try different strategies to get better results.
So instead of just a single retrieval step, you've got these agents that can think about the query, make adjustments, try different approaches. That's pretty cool.
Exactly. These agents can do things like context-aware query expansion, generating variations of the search query based on the surrounding information. They can perform multi-step reasoning, break down those complex information needs into a sequence of simpler retrieval steps. They can be picky about where they get information, choose the most relevant sources based on the query and what they've already found, and they can even use those evaluator agents to judge the quality and relevance of the information they've retrieved, decide if they need to keep digging.
So they're like those expert researchers, the ones who know how to track down the best information.
That's a great analogy. And the paper emphasizes that agentic RAG leads to big improvements in accuracy, explainability, and adaptability, making it super valuable for those enterprise applications that need high-quality knowledge retrieval, especially in those complex and constantly changing domains like law, finance, and scientific research. The key is those intelligent agents are in charge of the entire retrieval process. They're evaluating the information, deciding how to best use it. This dynamic approach is way more flexible and effective than that rigid one-shot retrieval of traditional RAG, especially when that information is always changing, always being updated. And there's even a diagram in the paper that visually compares agentic RAG with traditional RAG.
Now, for all those RAG approaches, whether it's the traditional kind or this fancy agentic RAG, the quality of those initial search results has got to be the foundation, right? Garbage in, garbage out, that still applies.
Absolutely. The paper stresses that effective search is the bedrock of any RAG system, and those agentic capabilities can then take it to the next level. If you're a developer working on RAG, here's the advice. Make that initial search as good as it can be, squeeze out as much recall as possible before you even start messing with the complexities of agentic retrieval. Nail the basics first.
Makes sense. So what are some of the techniques for boosting the performance of that underlying search engine in a RAG system?
The paper goes through a bunch of important techniques. Properly parsing and chunking those source documents into those meaningful units is essential. The paper specifically mentions Vertex AI layout parser and the concept of semantic chunking. You want those chunks to be meaningful, not just arbitrary pieces of text. Adding rich metadata to those chunks, things like synonyms, keywords, author info, publication dates, that lets you be more precise with how you boost, bury, or filter those search results. Fine-tuning your embedding model or using a search adapter can help your vector index understand the nuances of your specific domain, the lingo. Using a faster and more efficient vector database can significantly speed things up and improve accuracy. Implementing a ranker to reorder those top search results based on relevance is crucial, making sure the best stuff rises to the top. And techniques like check grounding, which involves citing those specific phrases from the source documents that support the generated answer, that adds a lot of credibility and trustworthiness. There's even a diagram showing those common RG and search components, and they mention specific Google Cloud tools like Vertex AI Search, Search Builder APIs, and RG Engine that developers can use.
This is all super practical, especially for anyone building those knowledge-powered applications. Now, shifting gears a bit, the paper talks about how AI agents are becoming more and more common in the enterprise. How are businesses actually using them?
The paper makes a bold prediction. 2025 is going to be the year of the agents in the enterprise. And it outlines two main types of agents that are emerging within organizations. Assistants, which are designed to work directly with users, help them get stuff done, and automation agents, which are more like those behind-the-scenes workers reacting to events, making those smart decisions to automate processes.
So for knowledge workers, this could be a big change, right? Instead of doing the tasks themselves, they might be managing those digital agents, more like overseeing a team of virtual assistants.
Exactly. The paper sees a future where knowledge workers become managers of agents. They delegate tasks, track progress, give guidance when needed, and use the output those agents produce. This shift will probably require new tools, new interfaces, designed specifically for managing those virtual teams of AI agents. And the paper points to Google Agentspace as an initiative that's trying to create that kind of integrated experience, a place where users can create, manage, run, and coordinate those agents within a company.
Let's talk about some of those practical enterprise tools. What is Google Agentspace exactly? What's it all about?
Google Agentspace is like this suite of AI-powered tools, and it's all about helping companies be more productive, making it easier to find information and automate those complex workflows, using AI agents to get things done. It leverages the power of Gemini, Google Search, and secure access to a company's data. The goal is to address those limitations of traditional knowledge management systems, those clunky old systems. Agent Space offers a more personalized experience. It can give you automated answers to your questions. It understands the context better, and it's way more efficient at finding the right info. Key features include the ability to bring in data from different sources, sync up with SaaS platforms, provide secure search and answers, and integrate AI assistants and agents right into those existing business workflows. It's all about making things smoother, more efficient.
And what are those core architectural principles behind Agentspace Enterprise? What makes it robust and secure for businesses to use?
The paper lays out a few key principles. Built-in trust is paramount. That means robust security, making sure those AI actions are explainable, not just a black box, and comprehensive governance controls so companies can manage access and permissions. It taps into Google's advanced AI capabilities, including machine learning, semantic understanding, those knowledge graphs, and large language models. It's designed to connect to all sorts of systems. It offers universal connectivity, allowing integration with a wide range of enterprise systems, and can refresh that data both on demand and automatically. It offers both company-wide customization and personalization for individual users. It incorporates those real-time feedback mechanisms for continuous learning and improvement, uses blended RE for optimal retrieval, and is built to handle those huge workloads. It's designed for scalability. And security is baked in from the ground up, leveraging that secure Google Cloud infrastructure with features like role-based access control, RBAC, VPC service controls, and identity and access management, IAM integration.
So it's not just powerful, it's built with security in mind. The paper also mentions Notebook LM Enterprise. How does that tool fit into the broader picture of AI in the enterprise?
Notebook LM Enterprise is like this super powered research and learning tool, and it's designed to help users make sense of complex information, process those documents, notes, all those sources you upload. Think of it as an AI research assistant that can help you summarize information, find those key themes, and really understand those large volumes of text. There are premium tiers like Notebook LM Plus with even more bells and whistles, but Notebook LM Enterprise is specifically for businesses, helping them find those hidden patterns in their data, unlock those insights. It even generates AI-powered audio summaries of documents, so you can listen to the key takeaways on the go. And it's built with enterprise-grade security and privacy in mind, using large language models for all that processing and text-to-speech for those audio summaries.
So it's all about helping businesses make better use of their information. And how does Google Agent Space Enterprise differ from that base agent space in Notebook LM Enterprise?
Google Agentspace Enterprise is described as a unified, company-branded, multimodal search agent, and it's like this central hub for all your company information. It offers conversational assistance, proactive recommendations based on what you're working on, and unified search across both structured and unstructured data. It can even translate languages on the fly. It comes with pre-built connectors for